Me again. Yeah, another video. Yeah, I have to do some writing, and I still want to do it, so I'll make an excuse of making a video. So anyway, I'll talk a little bit about Two Slit, and then we'll get to this stupid, idiotic, horrible, awful documentary. I've seen it already. It's that whatever Algid something or other guy. Just horrible physics. Profound distortion of the two-slit experiment kind of thing, and that's being used as if Einstein had any agreement with some of this notion of quantum. He didn't go for the spooky action crap. His mistakes are a different kind of mistake, pulling gravity instead of pushing gravity, big mistake. Creating the bend in space, time, which isn't a dimension, and putting all the energy in there, right? You have to have energy to move things. So he couldn't account for where the energy comes from, so what did he do? He creates a fake dimension, space-time, and the energy's there. That's where the hole happens, and the gravity pushes things down the hole. I mean, he's using the very force he's explaining with the force. I mean, it's just these kind of obvious gimmick. I mean, this is 4-card Monty or whatever the fuck it is. This is such a game here, a horrid game of fucking the truth. With these little magic tricks, with little perversions of reality. Alright, so two-slit experiment. So I did the single surface diffraction, and I found, with the laser pointer, that the real trick to it was don't allow the target to be too far away. So if you keep the whole experiment within 5 feet, so take a laser pointer, point it at the edge of a piece of paper, a flatter surface, credit card would be better. And you'll see, as you move the laser pointer to the edge, you'll see the little bits shoot out. You'll see it happen. The diffraction. So there you have single surface diffraction. I mean, isn't the game over already? And they're all, then you have single slit diffraction, which just means you doubled the surfaces, so the pattern's more intense. And then you have double slit diffraction, 4 surfaces, and it's 4 times brighter compared to the central maxima. And this is just so easy to explain, right? I mean, the double slit puts the surface in the middle. So the strongest light goes right up against the surface. The single slit, the strongest light is totally unaffected by the surfaces. And this whole idea that surfaces are oozing, I mean, we know in atmosphere we're oozing a ton of heat. There's a ton of radiation leaking out of us into the atmosphere. But even in space, I think you could figure out that although you might not radiate heat, there'd be no conductor for the heat, you're probably radiating electrons and ions and other forms of constituent nuclear bits. Just so obvious. I mean, it's obvious that there's a simple explanation. So Occam's razor all over the place, and it's so much more rational an explanation. It's just so, and they go for the irrational, convoluted explanation. And the experiment, like I said, these are not complex experiments. I mean, I'm supposed to believe Richard Feynman didn't know about single slit diffraction? That he never took, in his whole life, he never took a credit card and shined a light next to the edge of it and saw the light scatter? They had no idea that happens? No need to have 2 waves interacting with each other? None of that necessary. Come on. I mean, this is a hoax. This is like these guys are just saying, well, look, they stuck a Tyrannosaurus's head on a Brontosaurus's body. So what? Let's just go with it. Alright, Peking Man with 14 different gorilla skeletons? Who cares? Live the lie. It's fun. There's really no excuse. I mean, it's just like these aren't even experiments that are hard to do. The single slit experiment's not hard to do. Why are they talking about 2 slits being magical when the single slit does exactly the same thing? It's just not quite as eccentric, not quite as bright. That's it. No different otherwise. The little central bars are a little thicker, twice as thick, but that's it. No other difference. Yet there's something magical about the two-slit experiment. No, no magic. I'm just saying, if that doesn't smell like fraud to you, tell me these people can do, you know, complex calculus. They can do these derivative equations. They can know what a tensor is and a spandrel and all this other bullshit, and they can't sit there and figure out the surface is making the light move. It's just like the atmosphere scatters light, the surface is scattering light because there's particles around the surface of the material. Put your two damn fingers together on a white background and you'll see it happen right before your eyes. You'll see something happens. Before my fingers touch, somehow there's light doesn't get through anymore. A blob happens. And if you really look at it, if you have really good vision, you'll see that that blob has lines in it. And what might that be? Well, those might be the same lines that define charge. Another trick of magnetism. You know, people think the lines, like even when they draw it for a current, you know, the lines of the magnetic flux, the current's flowing through the white space. See, that's the trick. The lines, the field lines, are really lines separating the real conductor, which is the space in between. The space in between is the active space. That's the place the electrons are flying through. The field lines are the dead space. That's the quiet zone between the lines. Just like the quiet zone in the two-slit experiment. On, off. Just like Newton's ring. On, off. Same thing is happening with the movement of quanta, charge, around surfaces. It's just so obvious. I mean, I'm almost embarrassed it took me 4 years to figure this out. 4 years of amateur scratching at the bullshit. You know, spare time kind of stuff. But it still should have taken me 1 day. The fraud is so obvious. So, boo on the modern mystic for posting this as a meaningful contribution to mankind's understanding of reality. This is gross propaganda, full of distortions and overt, in my opinion, lies. So let's play the videotape, and maybe I'll do the whole thing someday. We'll go as far as we can go, and that'll be as far as we can go. I should be able to get some good insults in. Yeah. Fucking idiots. La 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 la. Show.
Beneath the complexities of everyday life, the rules of our universe seem reassuringly simple. This solid bridge supports my weight. The water flowing underneath always goes downhill. And when I throw this stone, it always flies through the air following a predictable path.
Right, so that should give you a clue that probably the mechanism creating all those rock-solid outcomes is probably rock-solid itself. No woo-woo necessary.
But as scientists peer deep into the tiny building blocks of matter...
Okay, when he says scientist, he means religious kooks. You know, whacking off to quantum unicorns.
All such certainty vanished.
Right, that's what he's saying. All certainty vanished because we drew the conclusion that two slits look like waves in water, and therefore we can draw conclusions, even though one slit doesn't look anything like waves in water. That doesn't make us think. Right? The fact that the single slit and the double slit do not act as predicted by quantum mechanics in both circumstances. They're not a parallel. It's not a good analogy because the analogy isn't consistent at all. The fact that an elephant's butt, little hole, could look just like a wildebeest's butthole doesn't make a wildebeest an elephant.
A found the weird world of quantum mechanics.
Right. Now, see, this is the worst part of the sin they've committed, is they've taken the words quantum mechanics, which really just means, you know, fundamental mechanics or particle mechanics or mechanics, you know, the underlying mechanism. And quanta just means quantizing, you know, understanding there's a discrete core bit. And they've taken that concept and completely broken it now, so you can't say quantum mechanics without implying magic. And that's just really, really, really irritating, because now I have to call it something else. It's like they ruined the word photon because they turned it into a wave. And it's a ton, it's not a wave. It's a thing that comes at a frequency, going the speed of light in a straight line. Doesn't think, doesn't wave, doesn't do any of that stuff. It goes where it goes until it hits something and goes somewhere else.
Deep down inside everything we see around us, we found a universe completely unlike our own.
They found what they were looking for, and worse, they deliberately ignored every sign that what they were saying was true wasn't true. That's what they did. This isn't a scientific investigation they did. These scientists are taking credit that they did something magnificent. They didn't do anything more magnificent than the Pope writing Bibles. That's what they did. They wrote a fucking story and called it the truth.
To paraphrase one of the founders of quantum mechanics, everything we call real is made up of things that cannot be themselves.
Cannot be real. Now, that sounds like a religion to me. Somehow the universe isn't accountable. It does things that can't be accounted for. It's not that we can't see it. It can't be seen. It doesn't happen. It doesn't exist. It's not that our tools are inadequate to pick at it, to dissect it. They're not even conceding that. They're declaring as a truth that it itself can't be anything that could be at all described.
Regarded as real. Around 100 years ago, some of the world's greatest scientists began a journey down the rabbit hole into the...
Yeah, this is getting to be so redundant. You know, the same journey story, as if all the past science validates their misinterpretation of simple observations. And never included in any of this, because they don't have the guts to say something stupid like Feynman did, is the fact that there were competing theories that they wiped out, that they burned at the humiliation stake, that if they had done any work at all in attempting to debunk them in anything but a casual manner, they would have realized that they have great weight as reasonable explanations.
Strange and the bizarre. They found that in the realm of the very small, things could be in two places at once.
So, that's what they found. Now, the evidence of that finding he's not going to show you. No way. Because it doesn't exist. There's no two places at once. Sorry, no. You have no evidence of that claim. That isn't something established by facts. It's established by your desire for it to be true, maybe. It's established by everybody else says so. It's established by a lot of propaganda, and that's all. Somebody wrote on a piece of paper, and all you assholes are just sitting there reading the piece of paper.
That their fates are dictated by chance.
Yeah, you'd all like to believe that. But no, the odds are explicit and inescapable. Determinism is the fact of the universe, it just is, and the laws that dictate the outcomes are solid. There's no chance. There's only outcomes. There's do or do not do, but there's really nothing there's no in between. Thinking about it is a fun little thing to do, But it has nothing to do with the do or the do not do. That's going to happen. I mean, the thinking is part of the process. I'm just saying that what you think is just part of the do. There's the preliminary to the do. You put your uniform on, then you pick up your gun, and then you go to the war and you shoot people. I mean, there's things you do before you do the shooting. That's all thinking is. But it's just part of the do.
That reality itself defies all common sense.
There we go. Reality itself defies all common sense. I mean, no, it doesn't. It doesn't, in fact, and the experiments really don't indicate that it does unless you pretend you can't analyze them rationally. But if you really do a little bit of rational analysis, again, you have two experiments, two-slit experiment, single-slit experiment. Both of them produce a diffraction pattern. Why are you paying attention to two slits and saying the two slits create two waves and the two waves interfere with each other and that creates the diffraction when the single slit creates the same diffraction? Why are you saying that? And then no slit creates the same diffraction. Why play this game like somehow the hole has something to do with it and it doesn't have something to do with the surface? The fact that they're physicists and it hasn't even occurred to them to realize that there are no surfaces technically, that every surface is made of atoms and that atoms have a bunch of empty space next to each other. It's not some kind of flat surface and things just skid right by. No, it's a big lumpy surface like the sun. It has all kinds of crap flying out of its edges. They're physicists and they doesn't occur to them to realize that there is nothing on one side and something on the other side in atomic structure.
And at stake, that everything we thought we knew about the world might turn out to be completely wrong.
Yeah, we thought when? I mean, you assholes have been chasing this quantum unicorn for 100 years now. So yeah, before quantum, yeah, people were, okay, it looks like bowling balls all the way down. And now you've turned it into unicorns all the way down. Fairy dust. You religious kooks. What was all that devil mask crap anyway? What are you all, Satan worshippers too? Got two religions?
The story of our descent into scientific madness begins with a most unlikely object. Berlin,
Ho hum.
1890. Germany is a new country, recently unified and hungry to industrialize. In this newly unified Germany, a number of new engineering companies were founded. They'd spent millions buying the European patent for Edison's new invention, the light bulb.
Zoom, zoom, zoom.
The light bulb was the epitome of modern...
Oh yeah, I've already done this. This is just too stupid, so I'm going to jump ahead. So eventually they'll get to Einstein's patent job, so here, let's move there.
Light of this intensity and colour requires a power of about 40 kilowatts. Now, that's equivalent to about 400 Ms on a bike.
Alright, so now he's talking about the energy, the intensity of light, and the fact that as it's coming towards you, blah blah blah, and then receding away from you, that you shift that color. I think he gets to that. And the fact that there's a temperature changes color, so the hotter it gets, the whiter the light gets.
Cycling very fast, or the combined output of the entire Tour de France. Although the light is white...
So it's very hot in there. Yeah, that's what he's saying. All the energy of the Tour de France in the little box. So then they look in the little box and say, ooh, it's very white in there because there's lots of energy in there.
It's red-white. There's very little blue. Why is blue so much harder to make than red? And further up the spectrum, beyond...
Right. Well, just understand that all it is the period between the photons. So blue is a tighter frequency. And it's harder to make X-rays. X-rays are really hard to make. So there's no mystery to this. You know, the spectrum. It's hard to make the things really close together because of the structure of atoms and the fact that they have to eject this stuff. and they have to eject it by some timing cycle. And their timing cycle can't be faster than the speed of light, so you can kind of get it that there's a minimum orbit in our solar system, right? I mean, if you were to spell a Mercury once every orbit, Mercury just split in half and it shot one of itself out into space. You can see there would be a period between those events. And you can kind of understand that to be a closer period, you need a planet even closer, or you need one moving even faster. And that's the trick, is certain speeds are going to be impossible because the sun is big and massive, and you can't get too close to it or you fall in it. So atoms almost theoretically have to be in some very unstable state to produce photons very close together. Essentially, cosmic rays are likely produced by explosive atomic catastrophes, not common events. They might be common, but I mean not, they're extraordinary. It's a consequence of instability in atomic structure, not regularity in common structure. That's why blue light is less visible, isn't produced as abundantly.
Blue, the so-called ultraviolet, is hardly produced at all, even when we look at things as hot as the sun. Even the sun, at a temperature of 5,500 degrees centigrade, produces mostly white visible light, and makes remarkably little ultraviolet light given how hot it is.
So again, they're just not getting that it's not about temperature, it's about stability.
Why is this? Why is ultraviolet light so...
Again, understand, X-rays are produced by radioactive elements. They're radioactive. They're falling apart. I mean, come on. Now let's scoot ahead a little bit. Well, we'll play this for a little while. I mean, this isn't two slit stuff, so I want to get to the two slit part because that's the part where, you know, I have a slam dunk.
Hard to make. This remarkable failure of common sense so perplexed scientists of the late 19th century that they gave it a very dramatic name.
Right. So this is the blue crisis or whatever, the blue catastrophe or something or whatever, the ultraviolet prison cell. But that's because they didn't understand what light was. They called it an electromagnetic spectrum when it has nothing to do with electromagnetic anything. It's a quantum spectrum. It's a frequency spectrum of quanta. And guess what? On the no frequency end of the scale, which is probably on both ends, in a sense. I mean, once you pull the photons a certain distance apart, you make a radio wave that's 1,000 million miles apart. Well, that's the same thing as having no frequency at all. So at both ends of the spectrum, you have gravity.
They called it the ultraviolet catastrophe.
I was right the first time. No, I said blue catastrophe, didn't I? Same difference.
Planck took a crucial first step to solving this. He found the precise mathematical link between the color of light, its frequency, and its energy. But he didn't understand. Right.
See, this is another one of these things that are just so, it's just so stupid. I mean, I can do it with my laser pointer. Yeah, we'll have a laser pointer. Oh, you can't see it. Well, you can see it a little bit. The point is, see, the light is just little dots at a frequency. Okay? So, you know, it's better just to draw them, but they're just little dots at a frequency. And the closer the dots are, the more energy, because there's more dots per second. So you just think of it as something going by you. And that's all it is. So the more dots that go by, the higher the energy, the higher the frequency. Cosmic ray, X-ray, you know, ultraviolet, light, you know, microwaves, blah, 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 right down the scale. No biggie. Radio waves at the other end. I mean, not complicated.
The connection. However, it was another weird anomaly that would really put the cat amongst the pigeons.
Yeah, no, I'm not saying there isn't something weird about anomalies. I'm not saying there isn't some experiments that are really, really complicated to explain, because there's a whole bunch of factors that go into the effect. You know, and some of them are atmospheric, some are happening inside the thing, some are, and so yeah, there's places where it's okay for physicists to say, holy shit, that's really interesting. But again, that shouldn't be part of their diagnosis. That shouldn't be something that's distracting them from just saying, well, what do we know about this experiment? What are the elements of the experiment? And what are those elements doing? And like in the two-slit experiment, it was just so simple. I mean, there's surfaces, and they just don't account for them at all. They just extract the surfaces from any conversation regarding the effect. And they're physicists.
In the late 19th century, scientists were studying the then newly discovered radio waves and how they were transmitted. And
see, and that's another problem. See, radio waves. They're not waves. The only thing that make them a wave is that they produce a ton of them at one time. So, see, they're lower energy in one respect, in that their distance is so far apart. Like you can have 3-mile or 10-mile radio waves. Obviously, most of the radio you listen to is pretty close by comparison. But it's still a very big distance compared to visible light. It's like the difference between 10 feet to 1 inch, kind of a difference. But when they produce them, they produce a huge number. So there's a huge number of parallel bits going at the same period, the same frequency. And so in a sense, radio waves can carry a lot more energy in one sense, in the sense you can produce a ton of them at once, where it's very difficult to create a bunch of unstable matter to create a bunch of light or something else, because that is going to require that you make the matter, the atoms, more unstable, that you create more of those very close orbits around the sun, where Mercury might fall in and go make a mess. That kind of thing. In some cases, Mercury does fall in and make a mess. That's probably what X-rays are. X-rays are basically Mercury falls into the sun, and the sun goes whoosh, and a bunch of shit flies out. Those are the X-rays, the shit flying out.
to do that, they were building experimental rigs very similar to this one. Basically, by spinning this disc, they could generate huge voltages that caused sparks to jump across the gap between the two metal spheres.
Right, so this thing is basically just shoving the charge inside the vessels, and so you can keep shoving 12 volts, 12 volts, 12 volts, 12 volts. You keep just dumping 12 volts inside of these round things, and they'll create a huge charge, and then you just run this thing closer together here to get your gap. So that's voltage. It's a type of transformer, but it's a really, it's not as good as a nice wire transformer. It's not nearly as efficient, and it's only worked for high voltages. Well, it works for lower voltages, but it doesn't have much storage capacity. That's probably the better way to say it.
But in doing so, they discovered something very unexpected to do with light. They found that by shining a powerful light source on the spheres, they could make the sparks jump across more easily.
Yeah, again, and now does that occur to you as being some sort of like, I wouldn't expect that you could, essentially, it's like semiconductors work this way, computers. So again, this is all connected. So in a sense, they were making the first semiconductor. But the idea that light, absorbed by something, would in some way energize the thing that's absorbing it. I mean, if it doesn't instantly just turn into heat and be radiated right back, you could understand that if the surface stays at all cool when it's getting hit by the light, that the light must be energizing. It must be going into the matter. It must be doing the E equals mc squared thing. It's being converted from plain energy, and it's being injected as extra electrons and other kinds of shit like that, and as stored energy, potential energy. And that increase in potential would induce, or help induce, the ability to shoot gaps, sparks across the gap. That essentially it would be extra electricity you were putting in, and that extra electricity would mean it would spark sooner. Right? I mean, that explanation was just off the top of my... I've never even studied this much. But I mean, it's just so obvious. Fuck.
Suggested a mysterious and unexplained connection between light and electricity.
Yeah, energy and energy. Now, does that make any sense? There's a connection between energy and energy. Right? I mean, are we surprised? There's a connection between energy and an energy. That's not a surprise.
To understand what was happening,
I mean, you know, this whole thing, like I said, I mean, this is like one of these kind of grammar school rules of physics and chemistry. It's the idea that matter converts energy. It takes in one kind of energy and produces another kind. I mean, it's just so... Don't we all know that already?
scientists use this. It's called a gold leaf electroscope. It's based...
Oh, see, this whole history thing is just so... who cares? I'm not saying that it's not an interesting invention. I mean, it's the static electricity. A little tiny piece of gold leaf moves up and down based on the charge.
Basically a more sensitive version of the spark gap apparatus. Now, first of all, I have to charge it up. What I'm doing is adding an excess of electrons that are pushing the two gold leaves apart. Now, first I take red light and shine it on the metal surface, and nothing happens. Even if I increase the brightness of the light, still the...
It's not really, see, he says that's red light, but what that is infrared radiation. So in a sense, you can kind of understand that that's just in a sense going to heat the surface. It's not really going to be able to inject photons into the surface. So that's the problem. That's the logical disconnect, is that that form of light, okay, we already know, just is completely associated with heat, and that heat is a radiant thing. That's a better way to put it. Well, you can sort of see the lack of energy in heat as the photons that come off of. This is the tricky part. You know, you can have an infrared camera, and what it's seeing is the photons coming off the hot surface. So the point is to make the surface hot is what this is doing. It doesn't get past the surface, so it just makes the surface hot. That's what I'm trying to say, is the infrared radiation is blocked. It's like glass being opaque to ultraviolet light. There's materials and a mica being completely transparent to it. So, you know, you could have a mica window and none of the visible light will get through, but all the infrared, I mean all the ultraviolet will. So that's what it's really about. And again, these are common things that they already knew even back then, that certain materials only permitted passage through their matrix to certain forms of radiation. There's things you can make hot easy. There's things you can charge easily. You know, they all have a different level of conductivity or transparency to the energy.
Gold leaves aren't affected. Now I'll try this special blue light, rich in ultraviolet. Immediately, the gold leaves collapse.
Right. See, so the ultraviolet light has got the tighter photons. They shoot right into the substrate, and they agitate the fuck out of it. Ding, ding, ding.
Light can clearly remove static electric charge from the leaves. It can somehow knock out the electrons I added to them.
Knock out. What's the right word to say? They changed the energy level, so they pushed Mercury back. So Mercury, say Mercury was close to the sun, by injecting the ultraviolet light, what you do is you give Mercury a little energy, and it gives it a wider orbit, and so it kind of stabilizes all the atoms that now from charge were getting close.
But why is ultraviolet light so much better at doing this than red light? This new puzzle became known as the photoelectric effect.
Now
The
we'll get to
ultraviolet
Einstein.
catastrophe and the photoelectric effect were big problems for physicists, because neither could be understood using the best science of the time.
Yeah, well, whatever. You say, I bet you there were people that were offering theories, and your fellow colleagues of the time dismissed it. And you just didn't pursue an explanation that wasn't suitably fun.
The science that said quite unequivocally that light was a wave.
Right. So he's saying that we're already set up for some sort of light as a wave thing. And you're just like, you have nothing. Nothing. A frequency does not mean wave. Lots of things have a frequency. Drops, dripping, it's a frequency. There's no wave involved at all. Nothing. Nothing.
All around us we see light behaving in a perfectly common sense, wavy way.
Common sense, wavy way. I mean, you're just like, no. It interacts with surfaces, and surfaces, it's almost like you say, the dripping thing. You see drops of water drop into a pond, and you see the pond turn that drip into a wave across that surface. As a rational person, you can understand why. These are two different things. One's a medium with tension, and one's dropping outside of a medium with tension. It's a conversion. That's what matter does. It converts one thing into something else in terms of the form of the energy. And so why would you think that when you shine light on something, you're seeing light? No, you're seeing its effect on the thing it hit.
Look at the shadow of my hand. It's fuzzy around the edges.
Well, there, a single surface diffraction. Single surface diffraction. He just did the fucking experiment right in front of us. He just did the experiment. And if he turned down the sun enough, he could really see the diffraction.
We understand this as the light hitting the sides of my hand and bending and smearing out slightly.
Yeah, bending and smearing out. I don't know. So why wouldn't you call it the two-slit bending and smearing out experiment? It's not bending, it's diffracting. So here's a scientist, and he won't even use the right terminology. The light doesn't bend. It's pushed. It's diffracted. It hits something, the something bends the light's angle, its trajectory changes. It's not bent. Light doesn't bend around fingers. It doesn't, theoretically, it doesn't, as Einstein argues, bend around suns even. Its direction is changed through interaction.
Just like water waves around an obstruction.
Just like water waves around an obstruction. I don't think it's, frankly, I think that's almost a silly thing to say, but whatever, let's go on.
Perfectly common sense.
I mean, obviously you put your finger in a water wave, the water wave goes right through your finger like it wasn't even there. I mean, the wave pattern is going to exist on the other side. Like your finger was just, I didn't even see that. That's what the wave is going. Oops, I hit your finger? I didn't even know.
Wave-like behavior. And here's something else. Something rather beautiful. Look at...
Oh, beautiful. Scientists talking about beauty. This should be like in the rule book of being a professional scientist. It's like there's probably rules for professional coroners, like don't laugh at the guy's small penis or something. There's certain rules. Scientists really shouldn't be messing around with this word beautiful.
These soap bubbles. Shine a light on them and gorgeous coloured patterns in...
Gorgeous. This just isn't like science talk. It's girly bullshit.
Emerge from nowhere. And this was easily explained if you accept that light was a wave.
Again, the necessity for light to be a wave to create like a what do you call it, a prism. There's no need to create waves to understand that the light is diffracting on the surfaces, that it's bent by the interaction changing medium, bends the trajectory of the light. Why does it have to be a wave to do that?
Reflecting off the outer and inner layers of the thin soap film and breaking up into the colours of the rainbow. Rather like ripples on the surface of water.
Right, so ignore the drip, ignore the period of the drip, the frequency, the fact that it has all the components of the wave, it has the same variables. Just ignore all that and say the drip is, so they take this and then they say this is what this is. No. Clearly it's not what it is. I mean, if you can't understand that the matter's this big thing that's complex, the surface, and the light's the simple thing, the drip, and that when you collide the light, the simple thing, with the complex surface structure, then you create this thing you might call a wave, but you don't have a wave before you get to the surface.
Light was simply ripples of energy spreading through space. And this was as firmly...
Right, so again, they take this and they push it back into the photon. The photon has this. This is not a conversion of the photon's energy. No, the photon itself is one of this. No necessity to do that.
Accepted as the fact that the Earth was round.
So they're making it this. This is conclusive proof. You just saw it. Photons are waves because they are discrete bits that collide with matter and create waves. So obviously the drops were waves. I mean, even though you clearly saw the drops being not waves, you clearly saw their discrete corpuscles that fell into the water. Forget that. You didn't see that. This is what you really saw. You really saw a bunch of waves come down here and hit there. That's what you really saw.
But although this wave theory works perfectly well for shadows and bubbles, when it...
Again, so does the particle theory. So this perfectly well thing is just... Yeah, the point is you can't use one... Again, it's the analogy. The fact that water waves duplicates conveniently two-slit experiment doesn't mean anything. As soon as you do a little testing and you figure out it doesn't duplicate on a single slit. So it just can't be used as a metaphor or a useful comparison. There's no fundamental mechanism in common.
Came to the ultraviolet catastrophe and the photoelectric effect, the wheels started coming off. The problem was this: how could light do this? To truly grasp how absurd this phenomenon was, it might be useful to consider how waves in water behave.
So again, we're just going to play with waves and say anything a wave does that looks the same, we're going to say that's proof. And every time the water waves don't look the same, we're going to say ignore that. That's what scientists do. So again, big bit falls in, makes wave.
This is the wave tank at the RNLI's headquarters in Dorset.
Wow, very exciting.
It's used to train lifeboat teams to deal with a range of different kinds of water waves.
Oh, very interesting again. This part I think is boring, but let's play a little.
First, small waves, just 30 centimeters high.
These waves get a pop of energy.
Alright, these waves, the energy in waves, I don't see any value in this, so we'll jump further ahead. Try and get the cat to shut the fuck up. You're a nag, you know that? Damn fucking pain in the ass bastard. Animals. I have to go feed the animals. The three of them. Anyway, so maybe I'll come back to this. What time is it? Oh, I can go a bit further. Let's jump out of this wave tank stuff. It's just kind of boring. Go there.
More intensity should knock out more electrons. But that's not what happened. Remember, no matter how intense the red light was, it still didn't budge electrons from the metal.
Right. Again, so this is not a mystery. Like I said, we understand that it all has to do with absorption. If it can't absorb it, it can't absorb it. The energy goes right through it. It has to have a matrix that can detect the frequency you're producing. If it can't detect the frequency, like the cosmic rays, they'll just fly right through me. If I don't have anything opaque to cosmic rays, they'll just go right through me.
But weirdly, weak ultraviolet worked within seconds. So thinking of light as a wave just wasn't adding up.
Right, so you should have just said, there, that's enough, okay, we understand, waves just really isn't work for this mechanism, let's be rational, but no, they just fell right back into the trap.
To resolve this, someone needed to think the unthinkable. And in 1905, someone did. You may well have heard of him. His name was Albert Einstein.
And unfortunately, he was wrong about a lot of stuff. Right about E equals mc squared. But everything else, space-time, canard, trick, rabbit out of the hat bullshit, and the whole relativity nonsense, time dilation, no, clocks break, that's all. You can have a clock that's reading real time, and everything else is just a clock moving at some speed where its metabolism is degraded. Doesn't tick as fast. Let's see. No reasonable definition of reality could be expected to permit quantum mechanics. There you go. You got that part right, and then he jumped ship and invented space-time. Yeah. Oh, now they're doing the penal thing. Phallic symboling.
This is the
We have a boner for space.
Sternbach Observatory in Berlin.
A very big boner for space.
Perched on top is a strange, huge iron and steel construction.
The Jew cannon. Yeah, they can hit Jews from thousands of miles away with the secret Jew cannon. Sort of looks like a Jew cannon.
But it's not a gun. It's actually...
That's what all the propagandists say. Oh yeah, sure, it's not a Jew cannon. Looks like a Jew cannon. Looks like a Jew cannon, must be a Jew cannon.
a telescope. Built in 1896, the telescope was one of the largest of its kind in the world, and made the observatory the go-to place to engage and astound the public in new science.
There's a little nutsack over
Albert
there.
Einstein gave a very famous public lecture here on his theory of relativity.
Yeah, too bad nobody had a tape recorder. I mean, Edison already invented that, you know.
Which is, of course, what he's most famous for. But it's not the work that won him the Nobel Prize.
Well, there's histrionics. Let's go back and look at all the mistakes the idiots made. Why don't you look at your current mistakes, jackass? Asshole. Scientist man.
In 1905, he'd also come up with a new theory to explain the photoelectric effect.
Einstein's wiener got depressed. Nobody applauded his speech.
And what he suggested was revolutionary and even heretical.
Yeah, I guess that's what the that the kooks and the religious would call it's a heresy, not to be part of the unicorn theory.
He argued that we have to forget all about the idea that light is a wave And think of it instead as a stream of tiny bullet-like particles.
Wow, there, you got that right for a couple of weeks. And then he fucked it up.
The term he used to describe a particle of light was a quantum.
There you go. See, now that makes perfectly good sense, because it's actually, gravity is the same thing as light. It's just that you don't detect it. It doesn't have a frequency. You obviously can detect it because it moves shit into other shit, so it's quite obviously out there, but you don't see it. It doesn't convert instantaneously. It doesn't go in and make light. It takes it a while to go in and, well, I won't get into that. But it is energy, obviously. It takes energy to move shit. You want to move, oh yeah, we're going to move the earth. A number of feet per second or something. Yeah, that's going to take a little bit of energy.
To Einstein,
morning.
a quantum was a tiny lump of energy. And although in 1905 the word wasn't new, the idea that...
Why do they keep doing this? I mean, it's just so... What is that? I mean, I'm supposed to be doing science, and you got me thinking penises. I mean, just... What the... No one can logically say, let's not just do this telescope thing going up and down all day. Come on, let's do some science in here somewhere. Fuck.
Light could be a quantum seemed crazy.
Light could be a quantum seem crazy. No, it seems perfectly logical. Drip, drip, drip. It's perfectly logical. Ah!
And yet, following Einstein's heretical line of thought to its logical conclusion, solved all the problems with light at a single stroke.
This is the big until...
I'll try to explain how this helps using a rough analogy. Of course, like all analogies, it's far from perfect, but hopefully it'll give you a sense of the physics to help you understand why thinking of light as a stream of particles solves the mystery of the photoelectric effect.
Well, I don't know if we need that part, because I want to get to the part where you fucked it all up again.
In this analogy, these red balls represent Einstein's light quanta. And those cans over there are the electricity held in the metal. Now, in the original experiment, they made electricity flow from the surface of the metal by shining light on it. In my analogy, I'm going to try and knock those tin cans over using these red balls.
See, this is total fail. Because what he's not realizing is it has nothing to do with the size of the ball, right? So it's not what the ball is made of. That's not variable. It's the frequency. So if he would have kept that stupid telescope erect and then pointed out that if I wanted to knock it down, I could use the frequency to do it. I could use harmonics to knock it down. So essentially I could hit it with a small object and just bend it a little bit, and then it would swing back, and then as it's swinging back this way again, I could hit it again at just the right moment, and now it'll swing more. And then I could hit one more time just at the right moment, and it'll collapse. So I can use just 3 little pieces of energy, but if it's at the right frequency, if it matches the harmonic frequency, the wobble rate, the pendulum rate, the rate of its swing, which everything has, I can destroy it with 3 little red balls. And this is a physicist, and he didn't get that. Instead, he's sitting there saying, ultraviolet light is cannonballs, and infrared light is little balls. Even though it sounds wrong all over the place.
Absolutely no effect.
Well, you have to hit it to have an effect, asshole. I don't think he hit one of the cans in the whole fucking thing. Girly man. I mean, shit. Probably throw. The modern mystic probably is throw disabled also. That's probably why he posted this piece of shit.
That's just like red light. According to Einstein, each particle of red light carries very little energy because red light...
See, this is where Einstein's wrong. See, each particle carries, because Einstein's not thinking about the fact that the particles are the same. The wavelength, the period of their impact is all that changes. And so Einstein might have known that, but the way he just described it, you'd say Einstein fails because he doesn't realize that frequency is between the particles. I mean, frick. He quantizes something and doesn't realize that the quantity is at the end of the frequency, not in the middle of the frequency.
Has a low frequency. So even a very bright red light with many red light particles can't dislodge any electrons from the metal plate, just like the red balls.
Right. It doesn't, the electrons of the surface are not in a condition conducive to doing anything complementary, so they just spiral around and fly back out.
Now I'm going to use heavier balls, like these blue golf balls, and I'm going to try and knock off the tin cans with these.
So, see, there's, you know, I mean, you can see that this is just a wrong way to look at it, okay? Because it would be exactly the other way around. You know, the smaller frequency would be, you know, you could pervert it the other way and say the little balls at a higher frequency or the big ones at a lower frequency. But, I mean, this way of analogizing is just wrong. It's just how frequently they're hitting, and, you know, again, and the more per second. I mean, the higher the frequency, the more you can get in the second. So it's like the machine gun analogy. If I have a machine gun and it shoots one bullet, well, I mean, I could just pull the trigger and do it any speed. So I hit something like, you know, whatever, it doesn't matter, a tin can or something, not a tin, something solid or a cannonball, and I hit it with one bullet, and then an hour later I hit it with another bullet. An hour later I hit it with another bullet. You can understand that cannonball's not going anywhere. It's just going to keep reflecting the bullets. But if I pull the trigger and hit it real quick, all at once, then I'm going to break down the friction. I'm going to destroy through that harmonic action-reaction wobble, and I'm going to wobble the thing and it's going to start rolling. That's the proper analogy. He's a professional TV physicist. Went to a university. All that shit. I shouldn't have to explain this to him. I barely went to high school. Barely. And yet somehow I managed to be able to throw.
The ultraviolet light in the experiment. Now, each individual light particle...
It's just like such a girl.
...carries more energy. Because ultraviolet light is higher frequency.
So again, higher frequency. He's throwing things, and he doesn't understand that you're not displaying higher frequency. You're displaying heavier ball. It's not even close to a good analogy. I mean, yeah, I know your preamble to the analogy was, this isn't the best analogy. Well, why didn't you find a better analogy then, fuckhead? This is a stupid analogy. It's a deceptive analogy. You're misinforming. You're not informing. And this bad violin playing is annoying. Did Einstein play violin that bad? Play something nice.
Just a few of them, like a dim ultraviolet light, are enough to knock the electrons out of the metal plate and collapse the gold leaf. So, Einstein's idea that light is made up of tiny particles or quanta is a wonderful explanation of the photoelectric effect.
Well, like I said, though, if Einstein thinks that the particles are bigger and smaller, then it's not so wonderful. But I mean, the word quanta sort of implies that there's a standard. So I think he probably had that part right. I don't think he would have approved this metaphor.
I remember when I first learnt about this, being blown away by sheer elegance and
Right, that's another word that scientists really shouldn't, professional ones, they really shouldn't do this blown away thing. Just, yeah, not very professional.
simplicity.
But what's more, Einstein's nifty idea also helped solve Planck's mystery of the light bulb. There was more red than ultraviolet because ultraviolet quanta took so much more energy to make.
And again, let's just understand, it really doesn't take more energy to make it. It takes more